You must have little knowledge of complex number. If you don't have this knowledge, we walk you through along the course. Now, what are the aims and objectives of this course? By the end of each lesson, before you move to the next lesson, you must understand that lesson thoroughly before moving to the next one. And also, you must be able to solve problems relating to calculus without any fear. And you must be able to challenge the world with your knowledge in calculus. Now, let's try to solve problem. Now look at these questions. Using the first principle to find the following derivatives. Number 1, y is equal to x. Number 2, y is equal to 2x. Number 3, y is equal to 3x plus 5. Number 4, y is equal to 5 minus 6x. Number 5, y is equal to x squared. Now let's get started. Now, let's consider this graph, a straight line graph with a given point. So in here, let's call it x axis. Is the x axis. And here we have the y axis. Now, suppose we have this point. And this point, we have this point in the x-axis, and we take these 2 points here in the x-axis. And let's call this y1. Let's call it y1. And here, let's call it y2. And in here, let's call it s1. And here, let's call it s2. Now, so in here, you will see from y1 to y2, there is an increase. Suppose our y1 is 2 and our y2 is 10. There is an increase from this y1 to y2. So to get the increase from y1 to y2, or you call it a distance, we are going to say 10 minus 2, and which will give us 8. And let our s2 is equal to 3, and our y2, our s2 is equal to 7. So in here we have 7 minus 3, which is going to give us 4. Now in this place, we have taken uh, the increase in y and also the increase in x. So instead of this, we can write it this way and we say y2 minus y1. And here also we say s2 minus s1. So this is referred to as the change in x or increase in x. So we have dx and here we have dy as in change in y. So this delta, which is change, is known as delta, which means change. Now if we have dy, we means the increase in y, which is y2 minus y1. Now if we have dx, we means s2 minus x1. Now to find the slope of this graph, we call the slope, we use the symbol m, which is going to be dy all over dx. Now this is taken from the equation y is equal to mx plus c. So we can have our m to be equal to dy all over dx. Now let's say m is equal to y2 minus y1 all over s2 minus s1. Now suppose we have y is equal to x. So comparing it with this equation, that is y is equal to mx plus c. In this place, our c is equal to 0 because c is known as a constant c. So c is known as constant, or you call it arbitrary constant. While the m is slope or gradient. So in this case, our m is equal to 1. We merely look at it, the coefficient of x is 1 and c is equal to 0. So our m is equal to 1. Now let's use first principle to find maybe it's true that our m is equal to 1 in this case. Now we have y is equal to x. And let's take the change in both sides. Here we have y, add increase to the y, we have y plus the increase in y, which is equal to x plus increase in x. Now subtract y from this side and s from this side. We have y plus dy minus y, which is equal to x plus dx minus x. Now, the reason why I did it this way, we are going to subtract the real function from both sides. So at the left hand side, you subtract y, and at the right hand side, we subtract x, because we are looking at the change in y and also in x. So if finally y minus y is equal to 0, so we are left with the y in the left hand side, and also at the right hand side, x minus x is 0. So we are left with dx. We are left with dx here. Now, divide both side, both side by dx, by dx. So here you have dy dx, which is equal to dx all over dx. So dx cancel dx, So we are left with dy all over dx is equal to 1. So from y equal to mx plus c, and when y is equal to x, we conclude that our dy dx is equal to 1. So which is the coefficient of x. Now let's take more example. Now suppose we have y is equal to 2x. Now how can we differentiate this using this first principle? Similarly, we say y plus, sorry, we say y plus dy which is equal to 2 in bracket x plus dx. Now let's subtract y from this side, which is we are going to have y plus dy minus y, and at the right hand side we remove 2x because 2x is the real functions here. So here we have 2 in bracket x plus dx minus 2x. So in this side we are left with dy which is equal to, when you expand the bracket, 2 times x equal to x, and 2 times dx is equal to 2 dx. Then minus 2x. Now dy is equal to 2 dx. Now divide both sides by dx, you have dy over dx which is equal to 2 dx all over dx. Dx cancel dx, so we have dy dx is equal to 2. So normally when we have y is equal to mx plus c, and we have y is equal to 2x. So c is equal to 0 and our m is equal to 2. Now let's continue. Now suppose we have y is equal to 3x plus 5. How do we use first principle for this? We follow the same procedure. Here we have y plus dy is equal to 3. And remember, you are only looking for change in x. So you have x plus dx, then plus 5. Then y plus dy, subtract y from this side, minus y is equal to 3x plus dx plus 5 minus 3x 3x plus 5. So here we left with dy, which is equal to, let's expand the bracket. So we have 3 times x, we have 3x plus 3 dx plus 5. Then the minus sign, use the minus sign to open this bracket. So you have minus 3x minus 5. Now dy is equal to 3s is gone, 5 is gone. So we are left with 3 dx. Divide both sides by dx. So you have dy dx is equal to 3 dx over dx. Dx cancel. So we are left with dy dx is equal to 3. If you have y is equal to 3x plus 5, from the equation y equal to mx plus c, m is equal to 3, c is equal to 5. Now suppose we have y is equal to x squared. How do we do this? The first thing we are going to do, we find the change in y and also in x. So we have y plus dy is equal to x plus dx. Then the square of it. Now the next thing we have y plus dy minus y is equal to x plus dx. Square minus x square, because we are subtracting this x square from this side also. So we are left with dy is equal to, now let's expand this x plus dx square. X plus dx square is the expansion of x plus dx multiplied by x plus dx. So s times x, you will have x squared. X multiplied by dx, you will have plus x dx. And also dx multiplied by x, you have plus x x dx, and dx multiply dx, you have plus dx square. So x plus dx will give you these two. The addition of these two will give you 2x dx. So finally, we have the expansion x square plus 2x dx plus dx square. So here we have x square plus 2x dx plus dx square minus s square. Now s square cancel out. So we have dy is equal to 2x dx plus dx square. Now divide both sides by dx. So you are left with dy all over dx is equal to 2x dx all over dx plus dx square all over dx. Now you have dy dx is equal to 2x plus dx. Now limit dx to 0. So we have dy dx is equal to 2, is equal to 2x. Since the x, we limit it to 0, so we are left with 2x.